How does a boundary define a closed system? Imagine a container holding water that you do not want to spill or let anything in or out of. That container acts like a boundary in thermodynamics. It's a surface that separates the inside from the outside world. In a closed system, this boundary is special because it allows energy to cross but stops matter from moving across it. Think of it like a wall that lets heat or work pass through but keeps the water inside. In thermodynamics, a closed system contains a fixed amount of mass. No matter can enter or leave through the boundary, but energy can still transfer in or out. For example, heat can flow into or out of the system if the boundary allows it. Similarly, mechanical work can be done on or by the system, like pushing a piston. The boundary can be a solid wall, like the sides of a sealed container, or an imaginary surface drawn around a volume of gas. The key point is that the boundary is permeable to energy but not to matter. This means the total mass inside stays the same over time. If you have a piston cylinder device, the piston can move, changing the volume but not letting any gas escape or enter. The boundary moves with the piston, but the amount of gas inside remains constant. This idea makes analyzing thermodynamic systems easier. Since the mass stays fixed, you only need to focus on how energy changes inside the system. For example, a sealed coffee cup is a simple example. Heat can enter or leave, warming or cooling the coffee, but the coffee itself stays inside. So, the boundary defines a closed system by acting as a barrier that only allows energy to cross. It keeps the matter inside constant, making it easier to study energy interactions. This distinction is fundamental when applying the laws of thermodynamics, as it helps us understand how energy moves and transforms without worrying about changing the amount of matter.